Shannon Technology has been in the business of assessing aging ACSR conductors from 1988. Since that time, we have continually refined the testing process. Improving the reliability of the testing instrument, increasing the precision of the measured data, and enhancing the reporting process is our ongoing commitment to our clients. Our latest advancement is the inclusion of steel mass loss measurement. This feature complements the loss of galvanizing data from the steel core bundle. Loss of galvanizing is an excellent long-term remaining service life indicator. Once the galvanizing has been completely exhausted, measurement of the loss of steel mass can be used to refine the end-of-life point for the conductor. To qualify the conductor corrosion assessment system for steel measurement instrument, a high-voltage test facility that could energize an ACSR conductor to 450 kV was used. 2 sets of bare steel wires were attached to the outside of the test line. The first set was made up of 4 bundles of 0.9 mm diameter spring wire. Each test point contained twice the number of strands as the previous location. The second set was made up of 1 and then 2 strands of 2.74 mm diameter wires from a 7-wire ACSR steel core bundle. The CCAS-Steel instrument was passed over all 6 test locations and the data was recorded. The conductor was then energized to 450 kV and the test repeated. Both data sets were identical. To complete the live line qualification of the CCAS-Steel instrument, the tug and trolley with the coil attached are subjected to a sustained arc at 450 kV for 1 minute. At the conclusion of the stress test, the instrument must be fully operational. This is a much more extreme test than would be experienced in normal field operations. It serves to demonstrate the robustness of the design of the CCAS-Steel instrument. Both the tug and trolley with its sensor coil survived this test with no effect on their operational capabilities. Corona is generated from specific locations around the CCAS-Steel instrument when it is on an energized line. This is most noticeable at the bottom corners of the tug electronics enclosure and at the bottom rear of the trolley electronics enclosure. Corona can also be seen at the rear of the sensor coil. As the tug approaches the corona ring on the left of the image, the amount of corona coming from the base of the tug is reduced dramatically. This phenomenon is also apparent as the end of the sensor coil approaches corona points on the simulated conductor. This does not affect the operation of the instrument or the telemetry system. This CCAS graph illustrates the loss of galvanizing from an ACSR conductor. Somewhat less than 20% of the original galvanizing on the steel core bundle remains over most of the sample. The 8-meter section near the right side of the graph shows complete loss of galvanizing. Measurable loss of steel mass through corrosion will only occur once all galvanizing is lost. The 2 ACSR steel core wire samples show 10% to 20% of the original galvanizing remaining. The center wire strand remains fully protected and some galvanizing is present on the inner surface of the outer 6 strands. The bottom sample would produce a CCAS instrument response similar to the left side of the graph. The top sample shows an area with 0% galvanizing remaining on the steel core bundle. Loss of steel mass in this area is likely. This CCAS-Steel graph illustrates the instrument response from the test line with the 0.9 mm and 2.74 mm steel strands added. The fine wire samples can be seen attached to the underside of the test conductor. The CCAS-Steel instrument test log clearly demonstrates a measurable change in steel mass. The first 4 test points illustrate the resolution of the instrument. A 3% change in mass utilizing the 0.9 mm spring steel wires is clearly identifiable. A mass change represented by the single strand of wire from a 7-wire ACSR conductor represents a 13.5% change in mass. Note that the CCAS-Steel instrument response is significantly above background on both the 2-strand spring wire and single-strand conductor wire locations. For additional information on our conductor corrosion assessment system for steel, contact Doug Shannon at Shannon Developments Corporation.